Hello everyone. So in this video, I will going to discuss the problem E of the Codeforces round 669 div 2, which is Egor in the Republic of Dagestan. The problem is quite big, so I will try to explain in my words. So what is the problem is all about? Like we have m cities and we have m uh, directed roads, which goes from one city to another city, and there is no restriction that the second city, the destination city, will be the same, will be different from the source city. So that is, we can have a road from the same city to the same city itself. That is, there are self loops allowed. And other thing is that there are two kinds of road. We will say the road of type 0 and type 1. And that is, like there are two cities, they can be connected by roads of type 1 and 0 both, or maybe of type 1 or maybe of type 0 or maybe none of them. So we are given the role of the manager to assign the cities the number 0 or 1 in such a way that if we assign the number 0, then we can only go from that city to the other cities which have the number same as the number we have given to the city. If we have given the number 0, then we can only go to the other cities, which can be gone through the type 0 road. And also, what else is there in this problem is that we have to construct in such we have to give the number of vertices in such a way that the path from the city 1 to the n will be the greatest possible path, and also it is there that it should be the shortest path, that we should not visit the node like vertices again and again to make the path more big. But if we have to do that, then we have to do that. So that is what I will try to explain through examples. Let us take the first example. So here we are given three cities and four roads. One and two are connected by road of type 0. One and three are connected by 1. Two and three are connected by 0. And two and three are connected by 1. So let me try to explain what they have asked through the example. So here we have the city 1 and 2 are connected by a road of type 0, and city 2 and 3 are connected by a road of type 0 and 1. So I have told you there can be multiple roads between the same pair of cities, and also there is road from 1 to 3 of type 1. So what we have to do, we have to maximize the distance, maximize the path from city 1 to the city n, which is city 3, in such and that, so that like, and then that distance we have to output as the answer, and the color that we will give to the cities as 0 or 1 to all the cities, to all the n cities, we have to also output that as a string after the answer of distance. All right, and that is, let me try to explain further. So like if I give 1 as color 0, then I will go can only go from 1 to 2, not from 1 to 3, because I have given it as color 0. I cannot go from different color roads. Then from 2, if I give it color 0, then I can go from 2 to 3. And even if I given the color 1, then again I also go from 2 to 3. So it is, in this case we can optionally choose 0 or 1, and from 3 we can give it color 0 or 1. It doesn't matter because we have not to go anywhere from here, and this is our final destination. So and if had I have not done and gone through the way that I have gone through, like I mean, yeah. So like I mean, if I have given this as color 1, then I can only go through the color 1 road, which is 1 to 3. So in this way, I have reached from 1 to 3 in one step. Earlier, I have reached through two steps. So I have to color the roads in such a way that I have to reach the destination in the maximum steps, or even I can make this maximum number of steps as the infinite number of steps too. And how this can be possible? This can be possible through an illustration of an example. In that, what we can say, like if we have two cities like U and V, and let us say we have a road from the U to V, a straight road, and we have also between them some bunch of nodes, and in such a way that the bunch of nodes are not visited. So what we can do, we can construct a path. If it is possible to construct a path of type according to the color, and then we will try to go from U to V through this path. And so what can happen then when this path can become an infinite path? As we know, in a directed graph there can be a cycle too. That is, so if there is U road, so it may happen that this bunch of nodes that we are trying to maximize our shortest path with, uh, have only one option. Like for example, here we have V, but instead, control that. But instead, because we have come out on the long path, then just a minute. Yeah, so let us say we don't have a path from this node to this node directly, and instead we have path like this. So what we will do, we will gonna have an infinite path to reach this position. It means that we will never reach this position, so the distance can also be infinite. So in this way we have to choose such kind of paths which have bunch of nodes between them, and such a way the distance can be infinite or a finite but is large finite. So what is the strategy? What is the technique to solve this problem? I have found a really cool technique to solve this problem. I think this can be useful in other problems as well. But for the time being, let us try to understand this problem with that technique. What the technique is all about. First of all, we will try to, we have two kinds of rods. So what we will do, we will distinguish the two rods by adding some bunch of vertices. That is, like for example, in this case, we have a rod of type 0 from 2 to 3. Then what we can say, uh, for to distinguish the type 1 rod, we can add a vertex, another vertex of number 2 plus n, which is 2 plus 3, which is 5. And then we can construct the rod from 5 to 3. So in this way, if the number on the vertex n is greater than equal, okay, it is not n, let us say, so the number on the vertex, let us say this is a number. So if this number is greater than or greater than n, it means this is rod is definitely of type 1. And if this number is less than or equal to n, then this rod is of type 0. So in this way we will construct our graph again, and then we will try to go through the technique of shortest path on this new graph. That is, here for the first test case, I have constructed this graph, that is 1 to 2, 2 to 3, but now instead from 1 to 3, a one road path, I have added 1 plus 3, which is 4, and 2 plus 3, which is 5, and I have also added this vertex n plus n, which is 6, which can be useful in other test cases. So what we are going to do then, from we will have a queue as we do in the shortest path. We will initialize the destination distance as 0, and we will color the destination city according to the number when we first found that. Let us say here 6. When let us say we found first 6. So then what is 6? We will try to, because 3 and 6 represent the same city, so then how can we know that they represent the same city? That is, the modulus of their from n is the same, that is 6 mod 3 and 3 mod 3, which is 0, is the same. So we will say we have visited the 0 vertex and we will initialize the distance. I have told you, if the color or if the number of the node is greater than n, then we will initialize the color as 0. If it is less than or equal to n, then we will initialize the color as 1. But if we have visited this node first, then in the very end also the color will remain as 0. If we have visited this first, then the color will remain of this node as 1 as well. So you should try to understand, whenever we first visit the modulo of the same vertex, then whatever the color of that vertex, it will remain the same till the end. So for the sake of convenience, let us, just a minute, for the sake of convenience, yeah, For the sake of convenience, we can assume that we have visited this 6 later and 3 first. So that's why we can say the distance is 0 and the color is 1. So the color of 3 will always be 1. That is the remainder, this vertex 3 will have color 1. So now when we go to this node 6, we said it is already visited, so then we will go backward if it is already visited and initialize the distance of those nodes to be 1 plus the distance of this parent node. So that will be 1 plus 0, that is 1. And what will be the color we will give? If the number is greater than n, we will give the color as 0. But let us say now in this case we visit 4, 4 mod 3 is 1. So the color will be visited of 1 will be 1, but visited the color will be 0. So now let us say we visited 2 first and 5 later. So if we visit 2 first, then we will give the color as which is less than n or equal to n, so we will give the color 1. Here we will give the color 0, but it doesn't matter because we already colored it 1. Now 2 mod 3 is 2, 5 mod 3 is also 2. So we have come back to the same visited node. So we will go further back and initialize the distance further, which is 2, 1 plus 1, which is 2. And then also, since the color is already given, 1 mod 3 color is already 0. So our distance, the final answer will be the maximum of the distance of the node 1 and n plus 1. That is 4 and 1, which is 2. So this is our maximum distance. What will be the colors? Colors will be 0, and on 2 the color will be 1, and on 3 the color will be 1. So even if we have come here first, then the color will be 0. So 0, comma 0, comma 1 will also be a valid coloring. Let me try to show you how. So if you have colored this as 0, and then you will come here, so even if you color it 0, I told you, or 1, you can still reach here with a distance of 2, and here you can give the color 0 or 1 depending upon your choice, as we have given here the color 1, and here we have given in the our test case the color 1. Here it is already 0, so our answer will be 2, 0, 1 and 1, which is the answer, right? So let us try to understand this with the help of code. Hmm. So what we have here, we will initialize the number of cities and number of roads, and then if the number t is 0, then it will be the u will be pushed back, but if the number is 1, then u plus n will be pushed back for v, as I have told you already. And then we will have a distance array of a number of elements to be 2n, because we have 2n vertices, and we have the distance to be a large number, which we have taken as to be 1 times power 9. Then we have a queue, as we do in the shortest path problem. We will push the last node, because our indices are starting from 0. So we will then, what we will do, we will push the last node, which is same as 2n minus 1, because in my case I have taken n into n, but if the index is 0 base, so we will have to subtract 1 more. And then we have also a vector of colors. So what we will gonna do, we will kind of like pop from the queue, and we will take the modulo, and if it is not visited, then we will mark it as visited, and we will the color of the u will be checked that whether this is less than n. In our case we are doing less than or equal to n, because we have index 1 based, but here index is 0 based. So then we will give them the corresponding color and we'll continue, then we will not go further. But if this is already visited, we will not go here, and we will instead go backwards from that node and initialize the distance to be 1 plus the parent distance, the distance of x, which is our latest queue element. And in the very end, we will our answer will be the maximum of the distance of the node 0 or the node n. And then if answer is the highest number, which is we have in 10 to the power 9, so that means that we cannot reach to the starting node, that is there is a cycle, so the answer will be -1. And then if there is not like that, then we will give the answer and then we will output the colors. So I hope you understand some part of the discussion. It will be really useful. Really, I feel really good if you really like, if you really understand some part of the video, because that was my idea and that was my objective to add, let at least make some part of the video to be understandable. If not 100%, let us say it is 30%, 40%. It will gonna help you in further more problems, and in fact it is also helping me to do further more problems because it increases my understanding as well. So I also, as I always say, this is not a tutorial, this is a discussion. Do not take this as a tutorial. I am not a tutor, I am just a normal guy like you. So just so with this note, let us terminate now.